A flow meter is attached to in a hydraulic line that measures 12 gallons per minute. The line has an inside diameter of 100.5 inches. So we have some kind of like pipe. And that is 1.5 inches. So I have some pipe like this. I have some pipe. And then there's like some kind of meter. I don't know, some kind of meter. Ooh. Like a clock. Find the flow velocity where the fluid passes the meter. Okay. So, yeah, that diameter there, that's D, equals sketch and label all known and unknown values, 12 gallons per minute. That's volume per minute. Volume, remember when you have volume per minute, or I mean volume, that's I think it's flow rate. Volume divided by time, that's flow rate. And then if you had what distance, the distance that the fluid travels, that's flow velocity. Okay, so what is the flow rate? Well, measured in inches cubed per minute. So we have that conversion. That was 1 gallon per minute. That's equal to 231 inches cubed per minute. So all I have to do is just multiply 231 by 12. And so that's 2,772 inches cubed per minute. And what is the area of inside the diameter? What? Of inside diameter? Area of inside diameter of line. That doesn't make sense. That's not a good way to word this. That's annoying to me. What is the area of the inside cross-sectional slice? Whatever. What's the area of this circle there? If we cut it in half, what's the area of that cross-section? Well, that's just pi r squared. Whoops. I'm doing it backwards. Pi r squared. So we need to have the diameter cut in half. 1.5 divided by 2, that's 0.75. So r equals 0.75, and I have the area being pi times 0.75 squared. And that is 1.767. That's it. This was inches, so this is inches squared. Moving on to number 14. It says, what is the flow velocity where the fluid passes the meter? The flow velocity. We have an equation for that. We have the flow rate. I think this is it. We'll see. Times the flow velocity, equals the flow velocity times the area of the inside, the cross-sectional area of the transmission line or pipe or whatever. So, flow velocity, I want V. That means I need flow rate, which I just had, right? We just had that, didn't we? That was 2,772. 2,772 inches cubed per minute equals the flow velocity times the area. The area is 1 point. I'm keeping it in my calculator. I have it in my calculator right now. 1.7671458 blah 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 blah. But I'm only writing down 767. I'll divide both sides by 1.767. I'm actually dividing by whatever's in my calculator. So make sure you're not rounding in the middle. So this, yeah, I'll divide those two things. Really what I did, it was hit my 1 over x button, because this was already in my calculator, 1 over x button, and then I multiplied it by that. If you don't understand that, then just write the number down and do it like that. 1,568.631. This is flow velocity. So what were the units here? We had area, which was inches squared, inches squared, inches squared, and we had the flow rate, which was inches cubed per minute. So this would be, well, that cancels with that, so it's just inches per minute. Inches per minute. This is all very nice. Oh, not a problem. This is it. This is last one. That seems very quick. Alright, a hydraulic press must be used to press fit two components together in an assembly process. Oh, I posted a video about, okay, whatever. Fit two components together in an assembly process. The system must generate at least 775 pounds of force to perform. So immediately I'm saying F out. The output force needs to be 775 pounds to perform the press fit. The piston at the input cylinder is pushed with a force of, so F in. That it fit. Like, oh, on this is Star Wars. Is that his name? Finn, maybe. And has an area of 30 inches squared. That's the input. That's the input cylinder area. What do we call that? I'm just gonna say A in AIN. That was 30 inches squared. The output can use up to 15 cylinder. Ooh. The output can use up to 15 cylinders that are each 30 inches squared. Okay, so area out for a single cylinder, that's 30 inches squared. How many cylinders are needed? Ooh. Sketch and label all known and unknown values. I don't want to sketch it. It's just a press. There could be up to 15. It doesn't say there is 15 cylinders for this press, for whatever this machine looks like. I don't care what it looks like. How many cylinders are needed? Okay, well, I think we got to use Pascal's law, right? I think so. Well, I guess before that, though, it has to do this. How much mechanical advantage is required to gain the necessary force? Well, we know that mechanical advantage is just the, what is it? The input force on the bottom, F in and F out on top. The input force is going to be smaller, is it? I don't know if I recorded that or not. Whatever. So that's for mechanical advantage, and we have both of those, don't we? We do. That's 775 pounds. Remember, mechanical advantage doesn't have any units. It's just a characteristic of whatever machine we're working with. So you just divide those. So that's 3.1. How many output cylinders must be incorporated into the design? That's, I think, where we're going to be using Pascal's law. This is like the example on the slides, I think. So let's see. I know P equals F divided by A. I have the input force, that was 250 pounds. And the input cylinder area I have, what was that? 30 inches squared. So P within the press is just 250 divided by 30. And so that's equal to 8.3 repeating PSI. But because the pressure within the system is equal everywhere, it's also like the, I'm doing air quotes, output pressure. It's the same. So this can also be used, P equals F out, divided by A out. So the area of all the cylinders there. Okay. I know that the, I know that one cylinder has 30 inches squared. But this A out, that's the area of all the cylinders added together. So I'll have 8.3 repeating equals, the output force was 775, right? Yes. Pounds, and then A out. I don't know what that is, but this A out is the area of all the cylinders added together, however many cylinders there are. They're asking how many output cylinders. So I'm going to find the total area, and then I'll divide it by 30 inches squared, because that's just one cylinder, and then we'll see how many cylinders there are. So I'll switch those two values, and A out, I guess I'll do it over here. A out equals 93 inches squared, and then so that's the total area, and then I'm going to divide it by 30 inches squared to see how many cylinders I need, because one cylinder is 30 inches squared. So 93 divided by 30, that's, well, 3.1. Oh, that's the same as mechanical advantage. That's cool. 3.1. So if I have 3 cylinders, it won't give me enough. And I can't have 0.1 cylinders. I mean, they tell you that you can only have up to 15. You can't have 0.1. So it would be 4 cylinders. All right, hopefully that makes sense. Goodbye.